So what I want to do sort of quickly is talk a little bit about Grubb's test for rejection of outliers. And before we really get into it, we got to think a little bit about what an outlier might mean. So when you do an experiment, right, you do it with a certain amount of precision. That is, you try to replicate your steps as best as you can so that the result that you get from your experiment have very little variation. And actually, this is a pretty good set of data to look at right here. This is part one from experiment 4. A student did the titration and calculated the molarities. And what we're doing is we're looking at how close these data points are, right? And when you look at them, they do actually look like they're very close together. Now, how could we tell if one of these was bad? Like if you were to guess and look at these data points and say, one might be bad, which one do you think might be bad? And probably you thought this first one, right? It sticks out because it doesn't have the 1. It looks like it's far away from the rest potentially. So let's talk a little bit about what outlier status means, right? So let's take a look at these numbers this way. Draw a number line, and I'm just going to draw sort of a random number line like this. And this is, let's say, 0.1000, and then 1, 2, 3, 4, 5. So this is 0.1005, a very small range, and then going 5 in the other direction, I have 0.0995. And let's kind of graph where all these numbers are. Okay, so I have 1.001. I'm starting from the bottom actually here. 1.001, there's a number there. 1.003, I have a number here, and I have 1.004. And then 0.0998 would be 2 over on this side. So potentially what we're looking at with these numbers is that this one, I'll put it in red, is potentially an outlier, that it possibly doesn't belong with these 3 data points here. Now, let's say you did this experiment not just 4 times, but let's say, I don't know, you're being punished and you have to do it 1,000 times. I don't know why I would do that, but let's just say for some reason we did that to you and you had to do 1,000 titrations of the same solution, right? What you might get, here's my 0.1000, and there's my 5. I just missed it. 5, and this is my... So the same axes, right? And then I do a measurement, and I come up with these same values, right? So I might have, sorry, I didn't mean to zoom that. Just put my hand on the zoom button. You might have a data point here, here. So these are your first 4. We let you keep those, right? And then you had your potential outlier, and he's over here. And then let's say you did this experiment, and again, in the second trial, I'm just going to use a different color for the ink. And then let's say you got one here, and then you got one here, and then you have one here, and then maybe you're going to get, I'll use different colors for the second rows all the time. Maybe one here, and then you just keep doing this over and over and over again. Eventually, if this represents a count of 1 and 2, when you do it 1,000 times, the counts were going to be much higher, like hundreds or maybe thousands if you did many, 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 right? What you're going to end up with is a curve that looks something like this. Its average is probably right around here. And the tops of those lines are going to do something like that. The middle value is the most likely value. This is the average. And when you look at it like that, it's possible that this point belongs to the rest of the data. It just depends on how spread out these data points get. So what Grubbs did actually is he used the shape of this curve to estimate how far away a data point could be from the average and still and be considered not part of the group. Okay, so the test is to see whether or not the data point actually belongs. And the way he did the calculation is relatively simple, and then I'm also going to show you how you do the calculation on a spreadsheet. But the first thing that you have to do is you have to identify your outlier. I think this is my outlier here. Okay. He looks like he could potentially be far enough away. This curve, I don't have a good idea of the shape because it really only took 4 data points. Okay, so this is part of the difficulty of the statistics, is we only have 4 data points. It's very hard to reject a point that's out here, possibly, simply because we don't know exactly the shape of the curve. But in general, if you take lots and lots of samples, curve shapes look something like this. Okay. So then what we're going to do is we're going to do the following. We're going to calculate the average. And it has the meaning that you think it does. Add the 4 data points up and divide by 4, right? So then what we're going to do is we're going to take each data point, or the suspect data point, sorry, and we're going to subtract the average. And we usually take the absolute value of this, and then we're going to divide, okay? And then the next step is to take, this is known as the deviation. It's how far away it is from the average, right? And then we're going to divide by something called the standard deviation, usually given a symbol like S of x, or some type sigma n minus 1, or S n minus 1. But yeah, it has a lot of different symbols, and we're going to do that. And this is known as the Grubbs experimental value. It's GEXP, because this one comes entirely from data. And then what we do is we check this criteria. Oh yeah, by the way, the standard deviation is the width of this curve, I think right around here. Okay, standard deviation is related to how wide the curve is. And so really the deviation divided by the standard deviation is going to tell us how far away in terms of standard deviations this point is from the average. Okay, so it's a fairly simple value to calculate. Standard deviation is fairly simple. You just do it on your calculator. Okay, so we get a G experimental value, and then what we're going to do, and I'm going to pull this up really quick, is we look up critical values for G. And I'm going to give you a much larger table of this in a resource file where this video will be linked. But we have 4 data points. The critical value is 1.463. Now, and I'll include the text of that document. If G experimental is greater than G crit, this is the value you look up, okay, not the one you calculate. Then we reject the data point. So this is 1, 2, reject data point if, right, that condition is true. And then the third thing we'll do is we'll recalculate the average and the standard deviation. Okay, so let me show you how this is done on a spreadsheet, and then we're going to come back and look at the second set of data, because the second set of data is actually a little bit more interesting than the first set of data. Let me go to my spreadsheet. I have the numbers already in Excel. Oops, sorry. There. And I want to calculate the average. And all you need to do is hit the equal sign, and then type in the words A, V, E, and then you'll notice it says average, and then I use the up and down arrows, and then I hit tab, and it types the rest of it for me. Then I move the cursor up with the arrow, and now I'm doing shift and up arrow, and it's selecting the range C4 to C7, okay, and then I'm going to hit enter. If you want to, you can close the parentheses, but it'll do that for you. And that is the average of those data points. Now we're going to do the standard deviation. And we're going to do what's known as the sample standard deviation. This is the one that is depicted normally by these variables down here, okay? And I'm going to go like this, same thing, equals st, and then you see stdev.p and stdev.s, so I'll hit tab, that's what I want. I'm going to go up to here, and I'm going to hold shift and highlight the 4 data points and hit equals. Now, this is the standard deviation. It's pretty small, actually, which is good. And then what I'm going to do is I'm going to go ahead and calculate the Grubbs experimental value for this data point. So I'm going to say equals, and I'm going to do ABS and close parentheses. That's the absolute value. And I'm going to do the absolute value of this number, the suspect data point, minus the average. And that's the number I get. So this is my deviation. And this is going to be my G value. And to do that, I'm just going to hit equals again. And I'm going to take this number and I'm going to hit the divide key, which is the backslash, and divide that by the standard deviation. And I get a value of 1.27. Now, I have 4 data points. That means 4 trials, right? Going back, oops, sorry, I keep doing that. Going back to this table, 1.463 is my critical value. And 1.270 is less than 1.46, and I already forgot what the last digit is. 1.463, like this. So we keep the value. Okay, so in this particular test, it really just says you did a pretty good job. Your data points are close enough together. They're all part of the same group of data. Even though when we plotted it on a number line, I'll tell you what, I want that. On a number line, it looked like it could be far away. These are spread out enough that this can't be considered a separate group. That is, when this curve shape is actually drawn correctly, it must encompass this data point. Now, what happens, okay, if you have an outlier that needs to be rejected? And look at part 2, right? If you look at part 2 in this data, the 6 down data, right? You notice these are all 0.51, 0.049, 0.049, and they're very close to this value. And this one's 0.57. Now, if I'm drawing that on a number line, I'm not sure I can really fit it all in because this one looks like it's pretty far away. Let me give it a try and then I'll show you what I get. So this was about as close as I could really get to what is correct. This is 0.050. This would be, I forgot to put this down here, sorry, 0.045. And then 0.0575, oh, there's 5.7, so 5.75 would be way over here, like this. And then the next point's 5.10, so it would be here. Then 4.99, so I just put that next to the 5.0. And then 4.96, which is about a little over halfway, perhaps. Yeah, 4.96. Sorry, 4.96 is a little bit about halfway over here. So you'll notice that these are all clustered together and very close together. This is my potential outlier. Now, normally when you're trying to find an outlier, all you have to do is look at the numbers, and you only need to look at the highest value and the lowest value. Middle values are generally not the outliers. because they're in the middle, so they're closer to the average. The outlier is potentially always one that's the highest or the lowest. So we call this ranking. We look at the numbers and we rank them from highest to lowest. And with 4, you can just do it in your head. And you look for the highest value. And it turns out the first one's the highest value. Okay. The lowest value would be this one, but because it's so close to these, I'm pretty sure it's not the outlier. So now we're going to go and do the Grubbs test on Excel. And we're going to see if we can figure out whether or not this point is the outlier. So I'm going to do the same things, but if you set your data up the way I did here, what you can do actually is kind of nice. Okay, I'm going to take these values, I'm going to copy them, so let's Control C, and I'm going to paste them over here. And now what it's doing is it's taking the average and standard deviation of the 4 numbers that are above it here. This one doesn't have enough places in it, so what I'm going to do is I'm just going to add some places to it. I think it should be about 4 sig figs. The Excel doesn't do sig figs, so what I'm trying to do is make sure it has about 4. And then I'll tell you about reporting numbers. These should all have about 4, so I can drop 1 sig fig on all of them, like that. But it's actually, when these numbers, when you're looking at them, they're not actually rounded at all. They're from the calculations that I used a spreadsheet to calculate. All right, so what I need to do is get the deviation. And again, it's the same thing, right? I can take these numbers, the absolute value for the deviation of C. In this case, it's 1 again, right? Or C4. Not C4, I4. This is I4 over here. And it's going to be, let's see, I8. Okay. So I'm going to go ahead and type that in just so you can see it again. But just so you know, because of the way Excel works, I can actually just copy and paste this over, and then I get my deviation that way as well. But I'm going to do deviation so you can see it. I'm going to go a little faster because you can always pause it. So I hit equals, I'm going to do absolute value, and then I'm going to do of my suspected outlier. It's not always the first one, guys, okay? It just happens to be this time. Minus the average, close parentheses, that's my deviation. And my G value, this is my experimental value, I'm going to go equals this number divided by the deviation divided by the standard deviation. Now I have 1.48, okay? Now, what do I do with that number? Well, what you see is because there's 4 data points, right? The critical value that you look up, 1.463, is now smaller than this G value. So we write this, we say G experimental, or suspect is greater than G crit. So what we do is reject value, recalculate, left some letters. Recalculate average and standard deviation. So let's just write this out, though. I just want to make sure this is clear. 1.480, right, is greater than 1.463. That's what I mean by G sus is greater than G crit. Oops. Just want to move it over so they stack a little nicer. I'm going to drop it underneath here. I just want to move it out of the way. There we go. All right, so how do we do that, right? So this is the nice part about doing it on the spreadsheet. If this is my suspect value, I just delete it. Now, you'll notice what happened here, and you can ignore this. Once you delete it, these columns aren't valid, but here's your new average, and here's your new standard deviation, okay? Now, how do you report this number? So let me copy this. Oh, I want to copy this whole thing, and I'm bring it over to our little document we're working on. How do you report that number? It's a little bit big, huh? What you typically do is you write like this, 0.050, and then you'll notice here your standard deviation goes all the way out to the 1, 2, 3, 4, fifth place, right? So what you typically do, the fourth and fifth place, you record out to the same number of places as your standard deviation. So 1, 9, like that, and then plus or minus 0 point, and then 0, 0, 0, 7, 3. So there's a rule is keep this number to the same, to two significant figures, and you round this number to the same place, okay? So standard deviation is actually a more accurate way of doing significant figures, but it has to be calculated every time. Okay, so I hope that was a good enough overview that you're able to sort of replicate what I did, either using Excel or you can do it on a calculator as well. All the calculators that I recommend can do these calculations. But what I want to do next is sort of walk us through the process again. So summarize in steps what you need to do the Grubbs test. So the first thing we did is we calculated the average and standard deviation. The second thing we did really was we identified an outlier. And the outlier, right, is always either the highest or lowest value. So the term I use for that is called ranking. Rank the values, and then the outlier or potential outlier is either the high value or the low value. Now, let's say you can't tell, right? You can't tell, like, oh, that's the outlier. It's not clear to you. Really, the simplest thing to do is calculate the deviations and calculate the G-sus or G experimental values for both. And whichever one's bigger is the one that's the outlier. Okay. But once you calculate the deviation, that should tell you. So the third thing we did is we calculated the deviation. And I'll write that in a formula in a second. And the fourth thing we did was calculated G-sus. And finally compare. Wrong line. Compare G-sus to G-crit. And this value is looked up. And it'll be in the documentation that I give you to look it up in. And then finally, if G-sus is greater than G-crit, then we throw the data point out. We literally delete it from the spreadsheet. Okay. Throw out data point. And then you recalc. And this, I'm not going to put a 7 here because it's actually just part of this. Recalc, average, right? And standard deviation. Now, what happens, and people have this question all the time, what happens if it's not bigger, like say G sus is not bigger than G crit, the situation we had with this set of data, right? Then you don't do anything. You still keep your average and your standard deviation. So going back to this spreadsheet, that's this one here, right? I calculated G sus and it was smaller than G crit. So we keep it, which means these are the legitimate average and standard deviation. So again, I hope that's helpful. If you have any questions, feel free to email me or text me.